Hi, in this presentation we will study production systems. Production system will have three main components: the production rules, the working memory, and the recognized act cycle. The production rules, which are here with the mouse is moving, are gonna be expressions that are gonna have left hand side and right hand side. So the left hand side, what we see this C1 in this case is a condition, and in the right hand side we see an action. So then when there is a condition that matches on the working memory, we're supposed to execute that action. So going back here, so we're going to have a set of, we said that the production system has three main components. So one of them is a set of production rules. So the production rules will look something like this, okay? And each one of them by itself is called a production rule or just a rule. And then there will be some working memory that will contain the description of the current state, and um, that conditions may be matches one of the left hand side of the rules, and then in that case we will select, and that's the part that is the component, the third component that we recognize here, which productions will match that conditions that are in the working memory. Now we're not going to execute all the rules that are matched because it may be more than one rule that matches. Then we're going to have some type of conflict resolution system that will decide which one of the rules is the one that we're going to start. So by default, usually we say that the first rule is the one that is executed. So here again, so we have a working memory that is going to be checking for conditions. So then, and then we're going to be looking into this, and this is going to continue until there is no, I mean, when there is no more conditions found that execute any actions, that's when we end. Okay, so then this is the algorithm that we will use, that I want you to study just in the way that we're going to be checking for the matches or the pattern search in the rules. So I think we're going to have now everything clear with this example here. So here, this is my production system, system. Okay, so here in this example, we're gonna have 6 iterations. So this is when we start, and this is when we end. So we halt here, so that's when we finish. So initially in working memory, this is what we have. Let's see this like a kind of like a string. I mean, this there is something that has a meaning. So this is CBACA. So now what we do is we're gonna check if there is a match with the conditions that are in the left hand side. So we can go, and then again, we need to have a procedure how this is going to be implemented. So one way is that we can go from rules in order that we had that stored in the system. So let's go from 1, 2, and 3 and see if they are there. So here, is there a BA in the string? I see a BA. Then we add into the conflict set 1. The conflict set is the rules that will be matched by whatever information we have in the working memory that matches the condition. So BA is there, so 1 is there. Now CA, we see a CA there, so we're adding 2, and CB is there, 2. So now here there are 3 rules, all 3 rules are matched by the what we have in the working memory. Now we're only gonna execute one, we're only gonna fire one rule. So now we need to decide how is that we will make the selection. So for this example, what we're gonna do is the first rule. So like we're searching from, in this case, from left to right, and then the first rule is 1. So that means this is the one that is being executed. And for this example, what we're doing is this string BA is gonna be substituted by the string AB. So then here there was a BA, you see there where my mouse is moving. So now this is going to be substituted by AB. So now this is the new working memory. So again, this is just an example now. The challenge when we're actually solving a problem is to decide what is that we're going to have for the production system, how is that we're going to do the implementation. I mean, this is a very nice algorithm. Okay, so now again we do the same and see which one of the rules are here. And remember, when there is nothing else, that's when we halt. And in this case, this would be the way that it's going to be executing. So now, let's say is BA here. There is no BA. AB is not the same as BA. Then CA, it is there. So we're adding 2 in the conflict set. And then the CB is not there. Now, which one we're going to execute with the first one, and which actually the only one. So we execute 2, and 2 says replace CA by an AC. So the CA is replaced, rule 2, the now notice that the CA appears twice in the string, right? So again, when we're executing the rule, this has been executed once. So we were following that is whatever we find first. So the first CA is going to be replaced by AC. And then we continue with this process. Again, now we're going to check is BA here, is not, CA is here. So we got 2, and then CB is also part of the string. So these are the 2 rows. Now I need to decide which one is the one that is going to be executed. So we're going to execute 2. It 2 executed again was changing the first CA that we find by the AC. So now the CA is replaced by AC. And then we continue with the process until eventually we go here in 6, and there is no matches. Okay, so then for example is BA here, there is no BA, there is no CA, there is no CB, the conflict set is empty, then we halt. Okay, so here is an example of how we can implement this with a game. So let's say that we have the puzzle game and we want to use the production system to program an artificial intelligence application to play the game. So here, this is the state that says, okay, I mean, this is a possible state. Let's say that we start the game like this, and the goal is that we get into this state. Now, the actions, the possible options that are here is moving the blank, which in this case to the left. So that means left. In this case, that means the 7 is going this way, and then or up. So that makes sense. So we either go up, down, left, or right. That's what we can do. That's what we actually move all the tiles, and then we get into here. So now here, look at how we're modeling the system into production system. So here that's the rule. So it says goal is stay in working memory, and then if that's the case, we halt, and then if not, this is the rule. I mean, again, it's on us to make the definition of these rules. If the blank is not in the left edge, then there will be, like for example, in this case, it's not on the left, then we're gonna move um, to the left. So this will be the action. Okay. So here is the description of the conditions, and this will be the action, and we will do the implementation of this. Let's see on the next one. So here it shows, let's say, a sequence of how this can be implemented. So this is the start state. You see that here there are 3 possibilities. Now, if let's say that we start using this production system. So for example, let's say that this is my current state. So I just start. So this is what is in my working memory. My working memory I only have this. Now I go and see if this matches one of these roles. So is this the goal? No, they are different. So it's not the goal. So this is not going to be in my conflict set, right? So now is the blank not on the left? Yes. So this rule is going to be there, and then it's not on the top. Yeah, this rule also this rule is there. It's not on the right, it is in the bottom. So the only conditions that are not in my conflict set is the first and the last. So that means I got three possible rules, moving left, up, and right. And that's what we have here. So from here I got 1, 2, and 3. Now, once I have these, again, you had to design some type of um, conflict resolution rules, right? And we can combine these with, once we have this graph, maybe with what we have done with the greedy algorithms with A star, or I mean we can do a combination, or because for example here we can say, well, from here we go over here, this is the first one, and then we continue. Now here again, if this is the current state, again, which rules are the one that match? You see that it's at the bottom and it's on the left, so it's not the goal, is blank is on the left, is not on top. So in that case, I mean, we just follow I mean, whatever is the rules that matches here, right? We continue with the graph. But I mean, this is a nice example how we do the representation. Okay, now let's see another example on another possible. I mean, we're using solving another game. So in this case, let's say that we simplify this with this board, and then, and again, this is giving you the power of you deciding the structures that you're going to use, how you're going to interpret. Because when you look at this, you say this doesn't look like a production systems that we were using here that says something about a condition, and then a halt. Because remember, it is up to you how you store the structure. So in this case, for example, there are two components. So I could make the interpretation that here the first element of this function move is the condition, and the second one is my action. So if I'm on 1, then I go to 8. Okay, so if on 1, again I will go to 6. So this is one possibility, right? So this would be then my description of my production system. That can be also described as this. So if you are on a square 1, then move it to a square 8. And that's what it says here, 1 to 8, 1 to 6. So 1 can go to 8 or 6, 2 and 2, I got two options, either 9 or 7. 9 or 7, and 3, there are two options on 3, two options on 4. So each one looks that they had two options, right? So this is another way of describing. Now, let's see another way of implementing those rules for that game here. Now, over here. So let's say that initially we're on a square 1, and the goal is to go to square 2. So in this case, we can halt when we reach the goal, because in this case, if you're using the production system for this application, you want to win the game. So in this case, we're going to check. I mean, we can add into our program that says if the goal is in the working memory, then we stop. So here, we're on 1. That's what the current state. So we're on a square 1. So we're right here. What to do? So I got two options, either 8 or 6, right? So if I'm a 1, 8 or 6, so these are the only two rules that matches the condition, because nothing else talks about 1. So I have in my conflict 1 and 2. And then again, if I do the first rule, then I do 1. Okay? Then when I do 1, uh, that means 1, I'm going to move now to square 8. So now I'm on 8. So my current working memory is on 8. So in this case, the working memory is where is it, in which current state is the 9 on the board, right? So this is fascinating, I think. So you see, so 8. Now still, this is my goal. Like I'm using this here to compare. Is 8 equals to 2? No. Then my conflict set will be 13 and 14. Why? Because 13 and 14 talks about 8, the square 8. Then I'm going to replace it with 3 or 1, right? Once I apply. So I had 13 and 14. I'm doing 13, and 13 is, rule 13 says that 8 is going to be replaced with the 3. So here is a 3. Okay, and then from 3 is going to be 5 and 6. I'm going to execute 5, and 5 is probably going to say that replaces that with a 4. And then we keep doing that until eventually I get into square 2, and that's when I halt because that was my goal. Okay, so this is another way of explaining how is that we can go and understanding that maybe using some type of recursion with the path in the moves, because here the path will be the interpretation that there will be a sequence of multiple moves to take me from X to Y. So in this case, maybe I want to go from point X in a given part of the game. I'm right here and I want to go to this specific uh, state of the game, right? So there will be several moves that will take me there. So again, there are multiple ways that we can say, I mean, we can implement this. So in this case, this approach will be that we always start on that square one. If we now make it in this way, like a recursive way, defining path, the path is going to be multiple moves, then I can define the production system being in any, not in a fixed start state, but any other way of the state of the game, right? So look at that. Now we're not using like graphs before. This is another approach that we can solve the games. Now, there are other two ways of implementing this. The one is going to be called data-driven search and goal-driven search. And for and I want to speed this up because the video is being too long. So the difference is if from a goal I go to the start, and a good example for this, let's say that um, you're going with a doctor and somehow the doctor has the feeling that you have uh, certain illness. So then the doctor is kind of following a set of interviews or tests, because the goal is like the conclusion that the medical doctor is going to have once you go there for advice, right? Because you're not feeling well. Somehow the doctor says, I think this person has this. Let's say, for example, now that is the the COVID-19. Maybe they got this in mind and they're going to start doing some tests, and they go from the beginning of the system. I mean, it automated the system, then they verify it. Okay, so the other way is when they start the procedure, but they don't really know what is it that you have. So they start doing some tests, and eventually they get a goal, and the goal is kind of the conclusion of what you have. You see the different approaches in here is they think, let me do the test for COVID-19 because maybe that's what you have. And then if they go to the end, I mean, like that way, that in the way that we put the information, then it is. And here is, well, we don't know what you have. Let's see what the results is going to take us to, where they take us to, which goal, because there may be multiple goals. But okay, let's see. I mean, what I was telling you is a possible application of these two approaches. I mean, the goal and the data-driven. Again, these are tools that it will be our decision depending on the problem that we're solving. Okay, so here, let's see, there is something else here. So we say that we start. So now this is the start, and then the complete set is 6. So now this is the rule that we fire. And when we do that, we add in these elements there. So again, if we're doing the example of a medical doctor, or maybe this is a lawyer that is, I don't know, getting some aspects of the case, what we're adding is in the memory, we're not substituting like in the other examples. We're adding this to the working memory, but we don't go and use the matching for the start anymore, but we use these elements from the rules. So here is that, let's suppose that these are the results of some of the tests. So we're not deleting that from the working memory. We want to keep that information there. Do you see the difference? So we're keeping that information. And then we're not executing. Remember that we were doing the first rule before. Now is that it's like let's say this person met this condition, it met this, the 6. That's why we have this. So now we're adding the 5. So we're executing the 5. By executing the 5, we're adding the S to the working memory. Now is and 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 and, uh, and we keep adding, right? So when we execute the ones that now the matches is going to be the two, so the two is being added and so on. So look at the word adding, and the last one that we adding is the one that is being executed. And when we reach in this one, the case of one, we halt because we reach the goal. Okay, different ways of implementing this, and this is very similar to the last one. So we have here the one, and then again by fighting rule one, in this case, this we're adding the P and the Q. Okay, so that we see the approach that we have, and then now which one is the one that they match. So these are the rules that we have, and then we get in the 2, the 3, and the 4, and then look at how we keep executing the rules here in that different order. You see the order in which they are executed. So these are just algorithms and ways of following how is that we gonna do the which rules is the one that is gonna be executed in the conflict setting. The other one, remember we were kind of doing like we were eliminating those from the oops.